Today I want to take a look at hosting an AngularJS web application in Azure. For that, we are looking at three main components: website on the front, database in the middle, and authentication. The Azure website is going to be hosted on an app service plan. We have SQL Azure for relational database storage. And finally, we have Azure Active Directory for authentication and authorization. So who are you and do you have access to this particular app? The website would read and write data into SQL Azure, and Azure AD provides more of an umbrella for something that will come up as OAuth tokens with HTTP that verifies this traffic is coming from a legitimate source. As part of this, we do end up with WebAPI endpoints that are reading and writing to SQL, and those are occurring over HTTP using GET and POST methods. So that's the general architecture of a single-page app spa hosted in Azure. And for our JavaScript framework, we are going to be looking at AngularJS 1x here. So how do you put this all together? You've got a single-page app, you want to read, write to a relational database, and you'd like to make sure it has some amount of security provided by Azure Active Directory, that it's not just any HTTP post anonymous coming over the web. We want to make sure all traffic is from someone in Azure Active Directory, someone that is part of our Office 365 tenant. First, we're going to take a look at this project here, the AngularJS single-page app, calling an Azure AD protected web API. And for that, we'll go ahead and grab the clone URL and bring it down. So here we've created a folder that we can get clone into. Go ahead and provide the URL. So with the master branch downloaded, we can now see that we have a solution. We'll open with Visual Studio. Okay, and opening the solution, we get a couple of different prompts. That's good. And we have two projects within the solution. Essentially, there's an API on the back and a single-page app on the front. The single-page app is going to be the Angular GUI, and the API is the web API with the controller on the back end. And in the web API, you can see that there's an authorized property decorating the class here. And then we're bringing in a couple of different methods for things like get single item, post, put, and all of these verbs help with data modification. On the front end, we have our AngularJS application, which we can see with ng-app right here on the index.html. So that's the spa for the front end display. And then here's the controller for the back-end data access. To make all of this work, we do need access to SQL Server for somewhere to save the database entity, and we are using Entity Framework. So we need to provide connection string for services. By default, the project comes with local DB and a catalog called To-Go API. So that's the name of the database we're going to want to create, and we will need some location for storing it. All right, so here we'll go ahead and spin up a new SQL database and create a resource. And for that, we do need to generate an admin account, and we'll go ahead and use GRC password generator. So here we have some randomized passwords. These are high security, good place to work from for doing cloud services. And we want to make note of all of that and hang on to the admin credentials as well as the name of the server. Over here, and the database name. SQL Elastic Pool is a no. Go ahead and save those. Configure database. It will default to general purpose, provisioned, Gen 5, 2 cores, kind of a high cost. We want to take that and move it over to something more basic. So here we can move things down, and we can host a database of 2 gigs for only $5 a month. So the basic plan is what we'll select for this demo. Go ahead and click Create, and that'll provision the SQL instance. Coming back around to the Add Resource, we can pick out a web app from the Azure menu. And we'll do the same thing here. Select our resource group and give it a. For the runtime selection, we are going to go ahead and pick ASP.NET 4.7 to take advantage of Entity Framework and to take advantage of WebAPI. These are going to save us a lot of time and help with the connectivity to SQL. So we'll pick the latest ASP.NET, and we're on standard 100 ACU by default. There's a few different choices. We're doing kind of a dev test workload. So for this, we might come in here and check out some of the other options. You have things like custom domain, SSL for a B1 plan at $32 a month. On the S1, you're looking at $43 per month. S1 plans are fine. They have a lot of different features, including staging slots, daily backups, and really navigating this menu will help match to the workload that you need for your particular use cases. But here we have the F1, which is a free plan. We have the D1 with a custom domain. And I think for us, we'll go ahead and select B1. With everything selected, we'll do review and create to provision the new resource for the web front end. So now we have the SQL backend and the web front end provisioning in Azure. By navigating into the resource group, we can see that we have an app service plan, a SQL instance, an app service, and a SQL database. These are all the components we're going to need for hosting. First thing we want to do is go ahead and check out the SQL database and make sure that we can connect in. Here we can view a couple of the basic settings on the plan, including the server name. We're going to try to connect with Studio. From SQL Studio, we can go ahead and pick out our authentication, use a SQL service account. And here we want to provide the same credentials we used during the creation. It does prompt that your client IP has not been added. So with that prompt, you can either sign in from SQL Studio, or you can come over here to the Azure portal, set the firewall, and add a new client IP. It will go ahead and pick up your current address and click Save. I like doing it from the Azure portal. It's pretty easy. Just do Add, Save, and then come back over to SQL Studio and try to connect a second time. So here we are connected into the SQL database. We see a single database, no tables, brand new. But we do have connectivity, we do have access, and that's really what we want to go ahead and verify, that we are connected into SQL. You can even run a test query just to make sure that your connection is valid by doing something like select @ version, which will echo back what type of SQL that we're running. This is SQL Azure RTM. So now that we have a SQL connection, we want to go back over to Visual Studio. In Visual Studio, we have a couple of different settings here. We've got local DB, data source, initial catalog, sort of a connection string and a path. This whole string here for the connection string needs to be replaced. And we want to use what we have from Azure. So we navigate back over to our instance. And there's actually a piece in here just for connection strings. It's in the top right corner. So we'll open that up and find the right one for connecting from .NET. When you copy paste it, you'll see an indicator for your password here in the middle. And we'll need to go ahead and grab that, copy paste to overwrite, and make sure that we have the latest. Good deal. Now we've updated our web config file with a location for storing data. It's a really good start. Okay, with our database connection string updated, we'll go ahead and run the project and see what we get. It opens up localhost, and we get an error, 404 not found, and this is coming from Azure Active Directory bearer authentication. Coming back over into our web config, what we'll notice is that there's a section for your tenant, your audience, and your client ID as to how to register this Angular SPA in Azure Active Directory as a known application that we do want to use for authentication. Coming into the Azure portal, we can open up the app registrations, and we don't really have much here. So you can do this manually and register a new app, put in a URL, give it a description, or we could leverage some automation. So here we have config, and cleanup and configure. Cleanup is to remove the app, configure the variables. We'll call this single page.NET app, localhost 44326. There's a tenant name, there's an app ID, and this is what we're going to be leveraging to go ahead and register the app, and we're going to be doing that using PowerShell. So what I'll do is go ahead and update things here, and we'll register the URL as app ID URL. Yep. Okay, good. And then configures the script that will log us in and use these variables to go ahead and provision a new app registration. So we'll open up a command window. So here on the PowerShell command line, what we're going to do is navigate into that same directory. And we are looking for the automation folder. So we'll go up a level, clear things out. We are looking for app creation scripts. That's right. And we're going to execute the configure. So config has the variable, but configure will push the setting. All right, here we can go ahead and complete our login and let the PowerShell execute, creating the AAD application. Excellent. Now when we navigate over to the Azure portal and we reload the screen, we see a new line item, single page.NET app. And it even has our app ID URL, which is pretty fantastic. It's great to see that you can automate these things and really provision the application more readily just by using a little bit of PowerShell for where you're going to host it. Gives you that client ID, gives you the tenant ID, all of that good stuff. Now back over here in our .NET solution, we will close webconfig. In fact, we'll close down all of these files, open webconfig, and on line 15 and 16, we see the values injected from PowerShell. So by executing that PowerShell script, it really updated the configuration of our app, which is fantastic. And that's something that we want to make sure is covered, that we're updating the correct places in the code. This is for the .NET side. It also does a few other places involving the Angular front end. So I could come over and check that. Yeah, so over here under the app scripts folder, there's an app.js, and it updated that as well. It put down the client ID and the tenant, and it really is, mapping this into the router. So as we're navigating the different views, authentication is needed, and you can see a dependency up here in the AngularJS module that it's using ADAL Angular to handle the authentication. So by running the PowerShell script, we can update both .NET and Angular automatically, avoiding any manual mistakes with copy-paste, making sure we put the right values in the right places, and we can confirm by going to the Azure portal and seeing the new app registration listed in the portal. It's an excellent time saver, great for quality. When I come into the permissions for the app registration, I see there's nothing listed. I'm going to go ahead and add one. And there's a couple of different options we have. The biggest one is Microsoft Graph here. And we can take a look, and this will be application permissions. And we can do user read. User read, sign in and read the user profile. So this is for the current user, right? This is for the current user of the application. And in our two different settings up here, we want to make sure we're using delegated for the signed in user, because really we only need that one for that one current local user. We'll go ahead and grant it on behalf of the organization with the admin consent and say yes. Here you get a green check mark on the right that says it's granted for the entire organization. You can sign in and read the current user's profile. Those are the permissions we need the app to have. Back over on the Visual Studio side, we can build the project and hit F5 to run. Here we see our application coming up. We are on the home route. It says Home Sweet Home, and we have a login button in the top right. We'll go ahead and click Login, and that should do an OAuth flow. And now we see a new route available called User. If we navigate into User, This is beautiful. We have a full JWT token showing all the details about the current logged in user, email address, what organization, app, that kind of stuff. If we log out, it says that we're logged out, and you see that the user route has disappeared and the login button is now visible. If we log in again, we'll get a little pop-up, we'll get a redirect, stay signed in, yes. Doing that OAuth flow, we now have a third route for user and a log out button. So we can log in and out. And this experience, it could be hosted anywhere. We've got the local host URL that we told Azure about. That's what it's expecting on the app registration, but we can really host the app anywhere. We'll look at that next with publishing to an Azure website. But having all of this context about who the current user is and that they are authenticated helps secure our application. Now for data connectivity, we're going to navigate into the to-do list route, and we're going to see an empty UI with no data added. Here we're going to type in everyone's favorite, hello world, and we'll even add another couple of test records just to demonstrate that we're doing multiple rows, multiple records, and that we are saving data. As we're doing that, we'll switch over to SQL Studio and go reload what the database has in the cloud. Here we have select add at version, but we see a new table called to do. We can right click on it and send a select statement to a new query, take a peek into that table, and we're going to see all of the data that we just added in the web GUI with an owner attribute that's unique to that token. This is unique to the user who's logged in. So this is a multi-user partitioned application that as you have more than one user connected, they can all manage their own to-do list. It is not shared data. It's something unique to that one particular user. And here you can see the owner properties, how it's marking things, and that matches back over here to the sub property. So we've got an application, it's authenticated, we're saving our data. This could be multi-instance based on the partitioning for owner, and it's all secured using Azure AD tokens. If you're not logged in, you can't execute these same data calls. Now, just to prove the point, we'll go ahead and add test number 4, and we got our network tab displayed at the bottom to show the network transaction. And here you can see status 204 and then status 200. The 204 is adding data. That's where we actually post the data, and it comes back. And here's a big giant bearer token with all of our authentication. And we're sending it, here you go, test 4 with an owner attribute. Fantastic. Yeah, and then it comes back with a reply of 204, which means that it saved the data successfully. So, looking at this, if we were to right-click in Chrome and do copy curl bash, copying the one item is curl bash, we can actually come over here to REST Postman and import that text as a way of imitating the exact same request coming out of Postman. So we're going to name this one Postman number 1, send. There we go. There's the transaction executed. And by default, Postman has SSL verification turned on. We're using a self-signed certificate, so we're going to toggle that to off. So over here in the general settings, SSL verification turned off. Go ahead and close that. Execute again. There's our body. Yeah, there's our headers. Yeah, and there's a 204. Good. Come back over to SQL, reload it. There's Postman number 1. We added a record to SQL using Postman, and we were importing the text from Chrome's F12. So this lets us kind of, work with those data calls more directly and really interact with Postman and the HTTP post directly. So anything you see on Chrome, you can always do a copy curl bash. That'll bring that one line item into the clipboard. We can come over here and do import from text and paste it in. Great way to bring over all the authentication headers. You can see here we have 22 different headers. So there's a lot going on. You don't want to have to do that by hand. So that's one way of kind of showing the API call directly. Now, if we came in looking at those headers and we took away this one, the authorization header with the bearer token, and we tried to post, what we get in response is a 401 unauthorized. So the only reason our web application is working is because of this essential authorization token. If we don't have that auth token, there's no way to write data. Running this through Postman is an excellent way to verify your security, that endpoint is not going to allow data reads and writes if we take away the auth token. So we'll go ahead and reload the route here, let it fetch the latest data, and you can see the Postman record in the web GUI. That was created with an API call programmatically in Postman. However, it writes to the same location, the SQL table. So when we come into our application, we can still see that data, even if it was added from another location. Now, the final step in all of this is to move and pivot that web front end out to Azure and have it hosted in the cloud. Here we've got a URL, and we do have an empty Azure website. Now, our final step is to publish that local web application into the Azure cloud. Here we have an empty Azure website. And what we're going to do on this screen is the Get Publishing profile to go ahead and download an XML for how to publish. With that downloaded, we can go ahead and stop the localhost application, and we can do a right-click Publish on our web app. That'll bring up a wizard where you can import the XML profile you downloaded. And here we'll go ahead and select the Publish Settings file that we downloaded from the Azure portal. And we'll click on Publish. All right, with that successfully published, we can see the URL and one succeeded down in our console. We'll go ahead and take a look at this and see what we have. Beautiful. Here we're looking at our application, Home Sweet Home, to-do list. You'll notice there's no user tab, but we do have a login button. When we click login, we get an error, and this is expected. The reply URL doesn't match what's expected. That's because we're hosting it in a different location than where we started out. When we registered the app, we told it about the local host address. We never told it about this new address. So we need to go update our registration. Here in the app registration, top right corner, you'll see redirect URIs, one web, zero public client. And here we have the URL that we were using originally. We want to add another one. We'll go ahead and click on Add. We'll paste in the new address of our website, and we'll do Save. That allows us to support hosting our app in multiple locations. We'll put in the URL. It opens up. We'll do Login in the corner. And just like that, we got a seamless single sign-on because we're already authenticated. If you're logged into Azure Portal, Office.com, SharePoint, Teams, any other web experience with an Azure AD token, you already have that token in the background, and when you click Login, it's going to go ahead and pick that up and use it. So here we can come into the User tab, we can verify our identity, we do have Logout, we are seeing the user experience, and we are hosted on our new URL. From this, we get the same experience with the same data. We'll go into To-Do List. So here we see an error has occurred when it's fetching the data. Now, we know our SQL database is still online. There's some sort of connectivity issue. And I'm glad this actually happened because this is really good troubleshooting. So if we reload the route with F5, we can peek into F12 and we can see an error 500. That line item says 500 server error, and the response is an error occurred. Doesn't really tell us a whole lot about how. So back over in Visual Studio, the System Web section can have a custom error, mode equals off. And that'll provide more debugging detail. We'll go ahead and add that one line, custom errors, mode off, and we're going to publish our website again. Okay, now that we added custom errors off, we can come into To-Do List and we get a much more detailed error message. This is saying, cannot open server requested by login. Client with IP address 104 is not allowed to access the server. To enable access, use the Azure portal, set firewall rule, and have a little bit more detail. So this is actually saying our new front end is not allowed to connect to SQL. So coming into the Azure portal and looking at our settings, we have two options. We can add the IP number, not ideal because it's static and it's going to change, or we can toggle this to yes, allow the access from Azure services. We'll go ahead and change that to yes, hit save, and come back into our application. Only takes a second to update. We reload to the to-do list route. And beautiful. Now we can see that it's loading data. So, not only did we show how to provision the Angular spa on the front, the SQL database on the back, put both of them in Azure where they're hosted in the cloud, we also showed how to register the app with PowerShell for automation and quality. We showed how to confirm the security with REST Postman, that you can run an API call with and without the authorization header, that it will fail if we don't have that header. And we showed that when you publish a front and back end into the cloud, you may need to adjust the security on your database to allow Azure services, those other front ends, access to the data. In my case, we allowed the IP address of the local client, and we allowed other Azure services. So now we have a website running in the cloud that's protected with authentication, and it has a SQL relational database on the back, AngularJS on the front, and Azure tokens protecting all traffic.